Hey, what is up, guys, and welcome back to another live stream for this coding contest. Today is Thursday and it's 8:30, and we are going to attend this weekly contest 234 live on Code 360 platform. I'm not any sponsorship, I'm not going to sponsor this platform or something. I'm just trying to solve some sort of questions. So it's already 8:33. Let's start with the first question, and I hope you are able to listen my voice. And yeah, I think I'm 100% audible. Okay, so let's reload this and okay, participate now. It's already 8:33. Let's with this contest, and I hope my video and my audio both are audible to you. Okay, let's proceed further. Let's begin. Okay, starting with the first question itself. So let us read the question first. I'm zooming it a little bit so that we can understand the question. So the question says Alice and Bob have different total amount of candy. You're given two integer array, Alice size and Bob sizes. Okay, represents the number of candies in the ith box that Alice has, and Bob sizes represent the number of candidates in the jth box that Bob. Okay, since they are friends, they would like to exchange one candy box each, so that after the exchange they both have same total amount of the candy. The total amount of the candy a person has is sum of the candies in all the boxes they possess. You are asked to find a pair of candy box sizes x comma y. Okay, let's switch to the Python mode where x is the size of box Alice must give to Bob. Okay, so I'll try to dry run it here, and then we'll code the question further. So we have to find a pair of candy boxes, candy box sizes x comma y x represent x represent the size of box Alice must give to Bob, and y is equals to size of the box Bob must give to Alice. Okay, so this is the pair that we have to return in this question. And let me check in the C++. We have to return vector intent. It means we have to return a list here. Okay, so yeah, Alice minus x plus y is equal to, okay, so the final condition is sum of all the candies that Alice have minus x plus y that is given by Bob, and sum of Bob minus, oh I'm sorry, minus y plus x. So this is what we have to return. So this equation can be simplified algebraically, of course, yeah. So the equation will be um sum of Alice plus 2y is equals to sum of Bob plus 2x, and this will be simplified as y is equals to sum of Bob. See, we can do this question directly, but I'm trying to elaborate how you will approach and how you will solve the question. That's it. So don't don't be in hurry. And Alice, let me check if someone is commenting. Hi, the alchemist. Hi, brother. Actually, I haven't signed. Bro, your screen is not visible. Why? But let me check why it's happening. Just a minute. Let me check. I hope it's visible now. Tell me if it's visible. Tell me if it's visible now. Whether the alchemist, please tell me if the screen is visible. Type yes if you are able to see it. Otherwise, I'll have to check on my phone. Um, I hope I'm audible to all of you. Let me check on my phone itself that am I visible or not. Hmm. Okay, it's visible. Okay, thank you, brother. Thank you, brother. So let us continue with the question. So as you can see, the question was given as fair candy swap, in which we are given with two arrays, Alice sizes and Bob sizes, in which we have to find a pair X comma Y, in which X is the size of box Alice must give to Bob, and Y is the size of box Bob must give to Alice. So the given formula here is this, as we can see. So we have to simplify the formula, and we have to find the value of x and y. So after solving this equation, this is the mathematical equation. After solving this equation, I'll get sum of Bob minus sum of Alex plus 2x, and whole upon 2 is the value of y, and x can be found as the same way. You got my point, na? X can be found in the same way. So yeah, so return an array containing these two values x and y. If there are multiple valid answer, you may return any one of them. So we have to return any one of them. It is the same as copy and then paste, just the reversal of Alice minus Bob upon 2. You got my point, na? This will be y. Okay. So Alice minus Bob plus 2y upon, okay. So this is the value of x comma y. Now what we'll do is we have to only simplify this equation and nothing. You got my point? So we have to solve this question. Let us take an example. Then only we are able to solve this. So for example, in this question we are given with two examples in which the size of Alice sizes are 1 1. So it's for Alice it's 1 1. For Bob it's 2 comma 2, and the sum is 2, and here the sum is equals to 4. It's going black sometimes. Let me check here. I don't know what's going on behind the scenes. Let me check my phone for that. Hmm. um just a minute. So let me see if it's visible or not, and then mm, it's not visible in my phone as well. I don't know why it's happening. Yeah, it is visible. Okay, I can work on it. So let us try to dry run on an example. See, I can solve this question in very quickly just by coding and seeing, but my motive is to try to. I already told in my previous video. I'm not telling this time. Let's dry run this question. So I'm given with 1 comma 1 and 2 comma 2. So the sum of L is 2 and 4. So we have to return sum of Ls means 2, okay, plus, or I can see the value of y is equals to sum of Bob means 4 minus 2 plus 2 into x, okay, upon 2, and x will be equals to 2 minus 4, okay, plus 2 into y upon 2. Correct. Now solving this further will give us 2 plus 2x upon 2, correct? And this will give us minus 2 plus 2y divided by 2. And further, it will give us 1 plus x, and this will give us minus 1 plus y. Okay, you got it. So we are getting the relationship as y is equals to 1 plus x. Y is equal to 1 plus x. So we can return any value. We can return any value such that x is equal to 1 plus, I'm sorry, such that y is equals to 1 plus x. So our final equation is y is equals to 1 plus x for this case. Okay. Now for any value of y, you have to return x. Okay. So the value of y can be, for example, inside the Alice sizes, if I'm taking the first element itself, then what can be the answer is, if I'm taking first element itself, it means 2. Then the value of x will be 1, correct? So the answer will be 1 comma, sorry, 1 comma 2, correct? So we just have to find out the relation between x and y and just put one value and you will get the value of other. Okay, so let's code this. I hope you understood this question. It's very easy question. It's a mathematical question. So yeah. So first of all, I'll try to figure out the sum of Alice. So I'll take it Alice sum, that is equals to sum of Alice sizes. I'm sorry. And I'll take Bob sum, that will be equals to sum of Bob sum, correct? Now our equation will be y is equals to, I'm taking this equation, the top one. So how will I figure out Bob sum, okay, minus Alice sum, correct, plus 2 into x. So what I'll be doing is, I'll try to simplify it further. You got my point? I'll be right like this. This will be our equation at the end, but yeah, okay. Okay, so if this 2 into y will go this side, then how can we code it? How can we code it? Plus, this will be plus. We have to figure out the value of x and y. Um, let's say we are considering y as the first value. Main thing is this value should be even number. The main thing is this value should be even number, because for each value of y we are taking, we have to make sure that the sum. Okay, so this is the relation, no? So I'll be iterating over y value. Okay, so for each value of y, for y in Bob sizes, y in Bob sizes, if 2 into y equals to, I'll take this diff is equals to Bob sum minus Alice sum. This will be constant as always, and then I'll be taking diff what I wrote here, I think I wrote something. Okay, so 2 into y equals to different plus 2x. You got my point, na? So what we're trying to do is, for this value we're trying to find out if there exists any value inside x, that satisfy this equation. Correct. That is the intuition. So how we are gonna find this x? So what I'll doing is for x in Alice sizes, okay, then return x comma y. Otherwise, return -1 comma -1. Let's try to run this. What's the error? Bob some reference before assignment. Okay. Bob sizes. Okay. Okay, so it's working. Let's submit this code. It took some time just to explain you. Otherwise, I knew how to solve this very fast. So let us go for the next question. No worries. That is why I'm here now. I'm trying to explain you things. Okay. I hope my screen is visible. I don't know. See, I'm more focusing to solving the question rather than watching who is watching and all. So let's solve the second question. You're given two integer array nums1 and nums2 both sorted in non-decreasing order. So both the arrays are sorted in increasing order. Let us write it here. Nums nums1 and nums2 are sorted in increasing order. Okay. Your task is to find and return minimum common integer present in minimum common integer. Okay. We have to return minimum common integer. Very good. Very good question. Okay. So if there are no common integers, you have to return. So let us dry run this question. 1, 2, 3, and that's another one is 2 comma 4. So I'll be having a one pointer here and one pointer here, and I would like to keep it here for better traversal. I'll keep j here, and I'll try if array of I, I'll try the condition is if nums1 of I equals to is not equals to nums2 of j, then what to do? Move one forward, or see, since the arrays are in increasing order, so what will you do is I'll be going if nums of I is less than equals to nums of j, then I will be increased. Okay. Else if nums of I is greater than nums of j, then j plus equals to 1. Otherwise they both are same, so return that nums of I or j, whatever. This is the simple intuition. So let's code it. I hope you got this two pointer approach, what I'm trying to do it here. And our range will be till I is not exhausted and j is not exhausted. Okay. So I'll be taking m is equals to length of nums1, n is equals to length of nums2, and while I'll be taking two pointers, I is equal to 0, j is equals to 0, and I hope there are at least one element present. Correct. While I is less than m and j is less than n. If nothing found, then return -1. Okay. I'll try if nums of I is less than nums of j, then I is smaller. It means I need to be incremented. So I plus equals to 1. L if nums of I is greater than nums of j, it means array at the element at j is smaller, so increase the j so that we may have possibility that in the next element, in the next iteration, the value of I or j may be equal. Else we are equals to return nums of I, and it's non-decreasing order, so we have to find the minimum common, so it should work. Okay, it's not working. Let us see the error. Nums is not defined. Okay, buddy. Nums, okay, 1 and 2. 1 and 2. Here as well, 1 and 2, and return it 1. Let us see. Working, submitted. I took more time in second question. It's very easy question. Okay, let us go for the third question. Let's be quick. First, read this question. A peak element in an array is an element that is strictly greater than its neighbors. Okay, peak element strictly greater. You are given a zero index array, integer array nums. Okay, your task is to find out peak element and return its zero based index. If the array contains multiple peak, returning the index of the array of any of the peaks is acceptable. Okay, you may imagine that nums of nums of minus 1 is equals to nums of n. You may imagine that, okay, both the sides are uh, infinite, minus infinite, so that each element is peak. Okay, in other words, an element is always considered to be strictly greater than a neighbor that is outside the boundary. Okay, your algorithm should okay. So log n, log n means, okay, you know what, after doing a lot of questions, I just get what will be the solution here. Since this is log n, I will be thinking in the space of binary search, because at the end we have to find the peak element. It means this, it's a searching problem, and and the accepted time complexity will be log n. So I'll be going for binary search. Okay, let's see if I am able to do it. So let us switch to the Python first, and then let us try to dry run on the given test case. So our test case is 1, 2, 3, and 1. Okay, so finding the peak element, and it is given that you have to consider minus infinity and minus infinity both the sides. Correct. So what I'll be doing is, mm, I'll be doing is, here the peak element will be, you know what? Here the peak element will be this one, and you have to return, if an array contain return the index of any. Okay, so we can return the index of any peak element. You know what I'm thinking? I want to plot a graph for this. So how can I plot it here? I'm trying. So let us consider that this is our baseline, this is 0. So, or I'll say this is minus infinite. Okay, and this is given as 1, and this is given as 2, and this is given as 3. Okay, now again it is given as 1, 1. So that will come here, I guess, here. Okay, and this is again given as minus infinity. Correct. So I plotted this graph, and you can see that this is a peak element. It's the line is going upward and then coming downward. So what I'll be doing is, I have to find the peak element. So if I am trying to apply the binary search, then what I'll have to check, if the middle element, if the middle element, uh, I'll have to check if, for example, I'll try to dry run it. Okay, I'll try to dry run it. 0, 1, 2, and 3. Okay, so our low is equals to 0 right now, high is equals to 3 right now, and mid will be 3 plus 0 upon 2, that is equals to 1. Okay, so this will be the mid. So our nums of mid will be 2. Now I'll check if nums of low is, if nums, I want to check if I'm on this side or I'm on that side. I mean, I'm on this slope, 1 2 3 increasing slope, or I'm on the other side of slope. I have to find any one of the peak point. Now it may be more than that. In that case, what I'll doing, if is nums of low is less than, okay, it should be strictly less than nums of mid. Okay, and other side will be nums of mid is less than nums of high. it means we are on the increasing slope. So our low should be going on that side. You got my point, na? We are here, and our element which is on the lower side is, just a minute. I thought there's something, knocking my door. So what I'm trying to say, I am here currently. My mid is pointing to 2. So I'm standing on this side, this slope. Okay, you got my point. Now this is 1, 2, 3. This is 3, 1 in minus infinity. So I'm here. Now my lower element 1 is smaller than me and the upper element is greater than me. Now I want to go further. So in that case, I'm sorry. In that case, what I'll be doing is low is equals to mid plus 1. That I'll try to do. Okay. On the other case, if I am on that side, else if I am on that side, then what will happen? L if nums of low, if I'm on that side, for example, I have to consider another case. For example, I'll take this case. Okay, so I'll try to draw a graph for this. It's going till 6, so I'll start from here. So 1, okay, then 2, then again I'll have to write 1. So this is first peak, and then I have 3, so it will go here, and I'm sorry, here, and again I have 5, so it will go here. Again I have 6, so it will go here, and then again 4, so it will go somewhat, I think here. Okay, so we can see here that this is the first peak and this is our second peak. We can see, so we have two peaks. So in this case, what I'll be doing is I'll try to copy it. See, I don't know, but I'm trying to figure it out that how we can actually solve this question. So let's take 1, 2, 1, 3, 1, 2, 1, 3, 5, 6, and 4. So our low is pointing to here and our high is pointing to this one. Okay. Now what next? Now I'll be checking if I'll be checking the mid. The mid will be, I'll 1, 2, 3, 4, 5, 6. So our mid will be 6 plus 1 upon 2, 3. So at the index 3 we have 3. So we are currently here. Now our low, which is this, which is 1, is less than 3, and our high, which is currently 4, which is okay. So we have to go that side. So our low will come here, and our high will be here. Okay, got it na? Got it na? But even in this case, I was not at the peak side, because the 4 was greater than me. So I'll come here, my low will be mid plus 1. Now I'll again find the mid, and that will be 5. So I'll be checking if 6, if the low of 6, yeah, if the low of 6 is I mean, it was low of 5 in this, so we got the answer and we'll return the element at mid. Got it now? So we'll try to code it right now. Okay, okay, and what I can do is, since it's given that you have to consider that in the both side we have minus infinite value, so what I'll be doing is I'll try to append it first. So nums dot insert. It can be done in other ways, but I'll try to insert at zeros, float minus infinity, and nums dot append at the end, float minus infinity. So I appended start at the starting and at the end of the array, float infinity, so that now I can work on it. So now our array size will be n is equals to length of nums now, and our low will be 0 and high will be n minus 1. Okay. Now, while low is less than equals to high, I'll find mid, that is low plus high minus low upon 2, classical binary search. If I have to check now here, so if nums of low is less than nums of, I have to check strictly greater than. Okay, nums of low is less than nums of mid is less than nums of high. In this case, it means we are on this side. So what I'll be doing is I'll try to shift low is equals to mid plus 1. Okay. Next, LF, we are on this side. Even after that, we have to go further. So nums of low is greater than nums of mid is greater than nums of high. In that case, we have to shift high is equals to mid minus 1. So in both the case, we have to go on the top side. And at the end, I have to return uh, nums of low or high, whatever, because both will contain the same value, I guess. So yeah, num is not defined. Where I use num instead of nums here. Okay, okay, TLE. I'm getting TLE. So on the other case, I think I have not handled a few cases. So if nums is, or I can do it like this. Okay, okay. So what is the condition I'm missing here? I'm trying to find out nums. I'm trying to find out nums. Okay. So here I have 0, 1, 2, 3. Both the sides I have to go at, um can I use mid here instead of this? Can I use it? No, invalid. Else I've got a call. I don't know what's going on. Give me just 1 minute. I have to pick the call. Give me a minute. Okay, so done with the call. Now I was missing some sort of things. Okay, so I added these things. Okay, and now I'm going for this. Uh, and we have to return index now. Let us try. Wrong answer. So what I was doing is elif, let me run it again. So if this one is this one, then this. Okay, it's again TLE. Hmm. Okay, I'm getting TLE. So I'm getting TLE. Nice. I'm getting calls and calls. Am I doing something wrong? If someone is watching, please let me know. Am I doing something wrong here? I'm not able to get it right now. I'm getting calls and calls. Okay, dokie. I will go with 1 and n minus 2. Will it work? TLE. Okay, what should I do? I already appended this. Um, am I checking it correctly? Or I have to just check. Okay, what I'm doing, you know what I'm doing? I'm checking with the left, but I don't have to check with that. So in that case, I'll first yeah, I'll first remove it. I guess I can do it without even that. So yeah, 0, and this is n minus 1, and low is equals to low is then equals to high. Okay, now I'll be checking if it's in the left side. So nums of mid plus 1, nums of mid plus 1, uh, nums of mid is less than nums of mid plus 1. It means this side, we have to get this side. So low is equals to mid plus 1. Else, else another else in any case we have to come as mid. Let us check runtime error again. What I did is 0 low high n minus 1 unexpected indent. Okay, where I gave unexpected indent, this one. Okay, working. You know what's wrong I was doing is I was trying to compare this element with the first element. So why would it work? That is why I was stuck here. So what I did is currently is let us take with this example 1, 2, and 3 and 1. So 0, 1, 2, and 3. Okay. So my low was here and my high was here. Okay. And my mid was 1 here. So nums of nums of mid nums of mid was what? Nums of mid was 2 here. So I was checking in this case it was fine, but in this case it was not fine because I was trying to compare with the lower one. Instead, what I would have done is if nums of mid is less than nums of mid plus 1, okay na, nums of mid plus 1, then I have to be low is equals to mid plus 1 because I have to go on that side. On all the other cases I have to go for else high is equals to mid minus 1. But since I am using here less than, so I'll be going with mid. So in this way I was able to solve this. So let's try to submit it, and we'll go for the next question. 100% submitted. Okay, let us go for the next question. Russian doll envelopes. Nice question. Let us read it. So you are given a 2D array of integer envelopes of size n, okay, where envelopes of I is equal to w comma h wi comma hi represent the width and the height of the envelope. Okay, one envelope can fit inside another if and only if other both the width and the height of the one envelope are strictly greater than. um you know I'm getting a lots of calls today, I don't know why. So if and only if both the width and the height of the one envelope, okay, so if there is an envelope for 4 by 3 and another envelope for 5 by 6, then the 4 by 3 envelope can go into the 5 by 6 envelope. So it's strictly greater, correct? Your task is to calculate the maximum number of elements that you can Russian doll Russian doll, i.e. nest one inside another, like okay, okay. So you cannot rotate any envelope. Rotate, we cannot rotate, it means the sequence matters. So I'll try it with the given test case and try to figure out which logic is fitting here. Okay, so yeah, 5 comma 4, 6 comma 4, 6 comma 7, 2 comma 3. Okay, so in this case, if I try to sort it, if I try to sort the given array, if I try to sort the given array in increasing order, in increasing order of, for example, width into height, na? So it's given width into height, na? Width into height, width into, okay. Increasing order of width, then what will be the sequence for 2 comma 3? Then we have 5 comma 4. Then we have mm, we have 6 and 4, and then we have 6 and 7. So here what I can do is uh, this cannot come, uh, this envelope can be fitted here and this can be fitted here, but not this one. Now let us try to sort it with respect to height in increasing order. So what will be the answer? 2 comma 3 again, then 4 comma 5, then again 4 comma 6, and I'm sorry, 5 comma 4. The sequence will not change now. 5 comma 4 and 6 comma 4, and then 6 comma 7. Okay, so it can come under this, correct, and it can come under this. So the max answer in both the cases is 3, correct, 3. So let us try to the maximum number of okay, okay, okay. We don't have to stop, we have to go further and further. Okay, since all envelopes have identical dimension, they cannot be nested inside each other. The expected time complexity is big O of n. We have to figure out it in big O of n. Nice. But how can you do it without sorting the array? You cannot, एक minute, you cannot rotate any envelope. Okay. So it's a easy question, I guess. Then we can only check if this is the given sequence. Now we'll check if the height and the width both are smaller than this, then we can go here. But you know the maximum number of runs can be, yeah. But how can you solve in big O of n? You got my point now. How can you solve it without um I mean without sorting? How can you solve it? How will you figure out which one is less? It mean otherwise it will take n square complexity, na? You got my point. We have to compare each with another. You know, each other. You have to find all the combinations. Let me check how many of you are watching. I don't know. Watching. I don't know. Okay, leave it. It's 9:17 and my laptop is fully charged. I don't know why and how. Hmm. It was not supposed to charge 100%. Leave it. So, yeah, what to do? The expected time complexity is big O of n. How can someone compare? How will you compare? I'm asking you. How will you compare this with this in linear time complexity? I'll try to go with the greedy algorithm as I was saying. Okay, so sort based on width. Okay, sort based on width. In that case, sort of envelopes and lambda, I think it will automatically sort based on the first index. Okay, it will automatically sort. Auto sort based on first. And if both are same, then based on the second. So here I will get my order as this. Now I have to iterate on the sorted envelopes. So I'll be doing it envelopes dot sort. Okay. Now I have to write an answer and return answer from here, and a thing in the middle I'll have business logic. What is that business logic? So I have to compare. I'll take a previous. Is the size given as one? At least one will be given. So I'll be having previous, which will contain envelopes of 0. Correct? Now for I in range 1 to length of envelopes. Okay. Now the current will be envelopes of I. Okay. I'll compare if previous of 0, previous has two dimension, na? So previous of 0 is less than current of 0, and previous of 1 is less than current of 1. Then you have to increase the count. So answer plus equals to 1. Correct? Oh, now we have different cases. Okay. Other this will be okay. Else, on the other case, I'll try to update it, and it will go to the next, and then it will go to the next. Let us run this. Okay. Hmm. 1 1 1 1 1 1. Hmm. 1 1 1 1 1. I was not aware of this case. 1 1, then 1 1, then 1 1. What I'm getting? 1. How, brother? Hmm. Okay. Return answer if answer greater than 0, else 1. One more case. Okay. 1 1 2 2 3 3 4 4. 1 1 2 2 3 3 4 4. It is already sorted. So what will happen is I'm getting our answer is 0 initially. Now my previous is pointing to this, my current is pointing to this. So I'll be checking if previous 0 and 1 is I am not updating previous here. That is the problem. Will it work? No. Hmm. No, what's wrong with this question? I'm able to pass only three test cases. It's 1 1 2 2 3 3 4 4. Okay, so let us run for this. It's already sorted. So our current answer is 0. Now, 1 can be fit inside 2. So the answer will be 1. Now, 2. Now, here, I'm updating. I have to update it, na? This is the case when nothing is overlapping. One can be the case where L if previous of 0 is equals to previous of 1. In that case, I'll be going if the first and second values are same. Okay, 5 4 6 4 7 3. So if these values are same, then what I'll do, I'll continue, else this part. Let's see. Okay, one more test case. I don't know what's wrong am I doing. Hmm. So I was dry running it, na. Previous current. So it will fit inside this. Now this is previous and I'm updating it, na. No, it will not work. I don't know what's wrong I'm doing. Am I able to understand the logic correctly or not? I don't know, but I'm getting lots of call today. Give me 1 minute.